The purpose of this video is to show some examples which cover two additional log and natural logarithm rules. And these rules are, one, that the log of a product, a times b, can be expanded into the log of a plus the log of b. Additionally, we can go the other direction. You'll see in the last example in this video today that if I have an expansion of the log of a plus the log of b, then I can contract that into the log of the product a times b. The second rule is that the log of a quotient, a divided by b, equates to the log of a subtract the log of b. In other words, the difference of those two logarithms. So I could also contract the log of a, take away the log of b, into a single logarithm, the log of a over b. In this first example, we are going to expand. So here I have a product, and I have it specifically, this works for natural logs as well. I have the natural log of x squared times y cubed. I want to expand this, and so I can rewrite this as the natural log of x squared plus the natural log of y cubed. Now we've been working closely with the rule that says the natural log of x squared allows us to rewrite by pulling this exponent out in front of the natural log, and in this case we can pull our 2 out in front of the natural log of x and our 3 out in front of the natural log of y. And so to fully expand this, we've got 2 times the natural log of x plus 3 times the natural log of y. Second example, we want to expand again, and the goal is to expand, in this case, a quotient. I'll start by rewriting this as the log of r squared subtract the log of z to the 5th. Once again, we can pull our exponents 2 and 5 out in front of each respective logarithm, and fully expanded form then would be 2 times the log of r subtract 5 times the log of z. In the third example, we're taking the square root of this entire fraction, x plus 3 over x minus 2. And so I'm going to initially rewrite this using a fractional exponent. So I'll write this as the log of x plus 3 to the x plus 3 over x minus 2 to the 1/2 power. Okay? And so I'm taking the log of that fraction raised to the 1/2 power. Now, this is the same as if I raise a fraction to the 1/2. This is the same as the log of x plus 3 to the 1/2. In other words, the square root of x plus 3 over x minus 2 to the 1/2, the square root of x minus 2. And now we can separate, rewrite it as the difference of two logs. So I've got the log of x plus 3 to the 1/2. Take away the log of x minus 2 to the 1/2. And last but not least, I'm going to save myself some time and not rewrite. I'm out of room anyway, but I could pull this 1/2 out in front of that logarithm and pull that exponent out in front of this logarithm as well, and you can imagine how that would be rewritten. Next, what if I wanted to, so in the previous slide we expanded, now what if I wanted to contract? Okay, so in other words, rewrite this as a single natural logarithm. Well, in my first step, I know that this 1/4 can be pulled back up into the exponent location, and the same with this 5. Now the 1/4, remember, is the 4th root. So one way that I could rewrite this would be the natural log of the 4th root of x, which is the same as the natural log of x to the 1/4, plus the natural log of y to the 5th. So that would be step 1 in contracting. Now because I am adding together two natural logs, I can take this one step further and rewrite as a single natural logarithm, in this case of the 4th root of x times y to the 5th. I've contracted. Next example. Again, this 9, you can think of this as an exponent. M is being raised to the 9th. This 3, think of that as an exponent. P is being raised to the 3rd. And so I can rewrite this initially as the log of m to the 9th minus the log of p to the third. Now I've got a difference, so in this case if I contract I should have a single logarithm of a quotient. So I've got the log of m to the 9th over p to the third. And I've fully contracted. In this next example, we need to think outside the box a little bit here. We're going to say u is equal to the log of 2, and v is equal to the log of 3. And our goal is to write this in terms of u and v. So in other words, when I rewrite the log of 0.08 or 8/100ths, for example, my answer should be in terms of u's and v's. So it's going to take an example or two before this clicks. Watch. The log of 8 over 100, or 0.08, is the same as the log of 8 over 100. And I can rewrite this as, we know that we can rewrite this, separate it as the log of 8, subtract the log of 100. Okay? Now, if you think of 8 as a power of 2, then we have the log of 2 to the third. And if you think of the log of 100 as an exact value, recall that the log of 100 is actually 2. We know that from our discussion in class. So I can rewrite this now as the log of 2 cubed. That's a power of 3, the log of 2 cubed. Take away 2. I can pull my 3 out in front and rewrite this as 3 times the log of 2, take away 2. And we know that anytime we see the log of 2, we are to express that as u. And so in the end, we can express this as 3u take away 2. Now, that's a hard concept. Again, we had to kind of think outside the box, so this might be a good time to pause the video, rewind, and watch that again. And I'd encourage you to try these next 3 on your own before watching me do them. Okay, so the log of 60. Well, we're going to have to get creative here. The question is, how can I get 60 out of 2's and 3's, powers of 2, powers of 3, and potentially powers of 10? And we can use powers of 10 because we know logarithms base 10. So if you think about this, we could rewrite this, we could express this as the log of, instead of 60, I could write it as 2 times 3 times 10. 2 times 3 is 6, 6 times 10 is 60. Now, just as I can expand the log of a product of 2 numbers, I can also expand the log of a product of 3 numbers. So I could write this as the log of 2 plus the log of 3 plus the log of 10. We're told that anytime we see the log of 2, we are to express that as u. When we see the log of 3, we're told we should express that as v. And we know, based on our conversation in class, that the log of 10 is 1. And so when I rewrite this, I can express it as u plus v plus 1. In other words, if u is equal to the log of 2 and v is equal to the log of 3, then the log of 60 can be expressed as u plus v plus 1. It's a tough problem. How about the log of 50? Well, again, I would encourage you to pause, take a minute or two, and think about how you can express 50 as powers of 2, 3, and 10. Okay, one way would be the log of 100 divided by 2. 100 divided by 2 is 50. And so if I have the log of 100 divided by 2, I know I can express that as the log of 100 take away the log of 2. Once again, we're told to express the log of 2 as u. We know that the log of 100 is 2, and so I can rewrite this as 2 take away u. Last but not least, the log of the square root of 9/2. Well, I could rewrite this initially, similar to what we saw on the first slide, as the log of 9 over 2 raised to the 1/2 power. That's a square root, which is the same as the log of, 9 to the 1/2 power over 2 to the 1/2 power, which is the same as the log of 3 over 2 to the 1/2 power. Now we can expand. So I've got the log of 3. Take away, I'm going to skip a step here. Bear with me. Take away 1/2 times the log of 2. Again, the log of 2 is u, and so the log of 3 is, so that's u. The log of 3 is v, and so I could ultimately express this as v take away 1/2 u. Again, that set of 4 problems was quite challenging. I would encourage you one more time, if you think you need a second time through, rewind the video and watch those examples a second time. Next, find the value of the logarithm. So now in this case, we are given a numerical value for the log base u. So we're used to seeing base 10 and base e. They're saying any base, in this case u. The log base u of x is 3.17, the log base u of y is 2.85, and the log base u of z is 4.52. Find the value then of this. Well, I can rewrite this, I can express this as log of x, log of y, log of z in the following way. Log base u of x cubed plus log base u of y to the 4th minus log base u of z to the 6th. This is the same as 3 times log base u of x plus 4 times log base u of y minus 6 times log base u of z. At this point, we're going to do some substitution. This log base u of x is 3.17. Log base u of y is 2.85. Log base u of z is 4.52. And so if we wanted to clean this up, we'd take 3 and multiply it by 3.17. We'd take 4 and multiply it by 2.85 and add those two values together. And then we would subtract from that 6 multiplied by 4.52. And when I type that in, I get a final answer of negative 6.21.